Hey guys and gals, what is good? What is good today, this fine day? You beautiful, intelligent people, thank you for stopping by. Thank you for stopping by. Much love for that. Let's go. Lurkers and twerkers and y'all sandwich making workers. Turn it up. Turn it up. Let's go. Appreciate you dropping by. Lurkers and twerkers. Those of you that hit the play button, every single one of you beautiful, intelligent people. All legends. Legends! Yes, you are. Yes, you are. We're gonna get right to things here, guys and gals. Doing my best to speed things up. Get right to the content, all those sort of things. I've been doing a lot of shouting out in the beginning of the videos. And I just want you guys and gals to know, right? I'm trying to speed things up, get right to content, right? A lot of you probably just want to get right to learning, don't want to listen to me going on and on and on. That's okay. That's okay. I could handle it. And plus, you want to get right to learning. So, man, I can respect that. I totally can. Okay, I totally can. Let's go. Just want to, drop some more stuff into chat here. If you're part of the live stream, you get to see all the good stuff. Well, I don't know if it's good stuff, but a lot of spam. I'm done spamming. Okay, guys, that's it. I'm done spamming. I have a question. Do regular birds fly in the sky, see an airplane, and think, wow, that sure is one humongous bird? I know, my jokes are really corn doggish, but who doesn't love corn dogs? Come on. Man. Okay, so anyways, the shout outs, guys. You know, I appreciate you. You've heard it a lot. I've shouted you guys and gals out a lot. But I just want you to know, whoever you are, wherever you are, supporting the channel, every single one of you, peoples, man, much love. Thank you for the support. I truly mean that. We're going to get right to this, guys and gals, okay? Speeding things up here. It's great to have you. Thank you for stopping by. Quick heads up. We are doing a class/lecture over here, okay? A class/lecture. If your goal, aspirations, desires is to learn a coding language, oh, you found the right place. Let's go. Let's go. I'm Johnny with WhiskeyTango Sharp Coding. Doing C++ instruction over here. Doing my best as well. I'm trying, guys. Thank you for your patience and understanding. I'm also doing my best to explain and go over examples and whatever it takes. Sometimes I may over-explain, I don't know, but I just want to make sure whoever's learning, you fully get it and you fully got it, okay? If you already understand and you kind of have the idea, you know what's up, feel free to slide the play bar slider button forward, by all means. I know you're still around, so we're all good here. It's great that you're learning so quick. I love it. I love it. So yeah, this is a class/lecture. That's what we're doing here. Okay, put on your thinking cap. get your coffee or your mocha yoka lava jave or whatever you drink. I know that was just all random, but you get the idea. Get your liquids, get all comfortable, get your writing notepad, do your note-taking skills, take notes, make sure you review and all those things before the next stream, and yeah, you guys are going to be learning. Definitely you're going to learn, okay? There's going to be something. Lots of good stuff, lots of things to go over, so much goodness. Coding is fun, I'm telling you. Once you get it, man, you just can't stop. You're addicted. Yes. Okay, it's great to have you. Let's get right to it. Throw on your thinking cap. Time to learn, boys and girls. Time to learn. We were last stream doing recursion. We're continuing with the recursion. I'm going to go over a few examples, some more examples. We're going to do some easy examples, simple, basic examples, so that you get the idea, right? I don't know, a lot of different and whatever areas people teach in this kind of area, specific area, they make it all way too confusing. It's way easier than, I don't know what they're trying to do. It's like they think they found the secret golden chest where they're 100 levels deep in below a castle or something. It's so top secret. It's really not that bad. Oh, no. Okay, so yes, recursion. What is recursion? We'll kind of recap here quickly. I was going to check the stream also quickly. Recursion. Perfect. Just want to make sure that we're golden. Golden like the Golden Girls over here. Or is that like Golden Freddy? Either way, it's all good. Me and my kid, as an aside, went to see the Five Nights at Freddy's movie, the first one. Man, it was so good, it literally got an ovation. Not a standing ovation, but a literal ovation. It was that good. Second one looks good as well. If you're into that sort of thing, yeah, you're missing out if you haven't seen it. Okay, anyways, that was an aside, but let's stay on track. It's just movie talk. Movie talk, nothing special. Okay, not so bad. Okay, what is recursion? Here we go. We're going to go over, because I kind of read a little bit of the theory somewhat, but I didn't want to go too deep into the theory because I didn't want you guys getting all scared off and stuff, like all this terminology and lingo and oh my god, and then you jump out of your chair and you start running around in circles like your hair's on fire or something, your arms are flailing in the air and you're running around in circles screaming like a lunatic banshee, over dramatizing and overreacting and all those sort of things, and then you're tripping over your shoelaces and stuff even though you're not wearing shoes, and you're falling on your face and all, and where was I don't know, my face hurts. Okay, there's no sense, there's no reason to over dramatize. Okay, it's gonna be fine. Okay, it's gonna be fine. All right, what is recursion? Yes, so we'll get into the little bit of theory, right? We did a couple examples. Where are we here? So Here's an example. We're kind of just looping. Let's just build it. Is this built yet? We'll run this. Welcome, Kenny. Thank you for the support last stream. Let's go. We'll hit it 5 times. There we go. And that's it. So I'm getting a user to enter a value. And then basically it takes the function, takes in that value, utilizes it, and spits out that code however many times. Whichever n is the value that I entered, which was 5. It could be any random number as long as it's positive. Must be positive. Okay? Well, you can put 0, but you're just going to get a return. Or you could just return 1. Doesn't matter. It's all the same. Okay, so, and then this function here, literally every time, remember, guys, gals, when a value is updated or stored in memory, initially the value I enter is n value, okay? I put in 5, okay? It takes that value, right? It takes it in, and then it puts it in here into the function. This is recursion. It's a function that's basically looping itself, okay? But you need this here to actually make, to create the recursion instance. And what's happening is that 5 becomes 5 minus 1. And then the next time it runs it, n is going to be 4, right? Make sense? Mathematics 101. I know you guys and gals can subtract, right? You get the idea, and that's what's happening. And it'll keep going until it returns 0. That's what the base case concept is. You need that. If you don't have the base case, it's critical. It's for ending the operation. Okay, otherwise you would have just an infinite loop, essentially. And then all of a sudden you're running around your house, like your hair is on fire and all that, those sort of things, screaming because your computer's literally just going on and never ending. Endless loop. That is a no bueno. Recursion in C++ is a programming technique where a function calls itself either directly or indirectly to solve a problem. It's an alternative to iterative solutions. Here's a new word for the day. You must learn it. Iterate or iteration. We're going to get into that eventually. But that's a common coding lingo language word that you're going to want to know about. Okay, guys and gals, checking this, we're good here. Whoever is part of the stream right now, lurking and twerking, you're an absolute legend. I appreciate you every single time. You're dedicated, loyal. You are one solid individual. Solid. I'm telling you, you're solid. I respect that. I would have your back any day in a battle. Okay, in a hypothetical battle. Maybe in a medieval battle or some kind of battle. Anyways, let's continue. Just letting you know, I'd have your back. Certainly would. Okay, so it's an alternative to iterative solutions using loops like for or while. We haven't really done any loops yet. They're not so bad either, guys. Recursion is just another way of looping. Essentially, we're looping. That's what we're doing. We're repeating a situation until we get an end case, which is the base case. That's what stops it from continuing. You need that, right? It's kind of like, if you don't have brakes on your car, right, and you're going downhill, no bueno, no bueno. It's not good, right? The base case are the brakes, okay? Makes sense? Totally does. Key components of recursion. Base case, this is the termination condition for the recursion. It defines when the function should stop calling itself and return a value, preventing infinite recursion, right? Endless loops, in other words. Recursion case, right? You have base case and now you have recursive case. My bad for not saying that. I corrected myself. This is where the function calls itself with modified arguments, moving closer to the base case, right? That's what the arguments, these parameters, this parameter here, n minus 1, that's what brings it closer to the base case. Right here, this parameter is key. Key. How recursion works: when a recursive function is called, it performs some operations, and then, in its recursive case, calls itself with a slightly different input, right? Because the value changes every time, right? It's decremented, in other words. This process repeats, creating a stack of function calls. Okay, I'm gonna try to go over an example of what happens kind of on the stack, right? We're talking about memory. We're leading into memory, guys. That's what we're doing. We're going to be talking about LIFO a little bit. We're going to talk about on the stack and what happens under the hood. That's what we're leading into now. Okay, stick around. It's great to have you. Again, this is all part of the great thing about C++. It helps you have a better, stronger, much stronger understanding of what happens under the hood when you run a program or application, more so than any other language. Just going to throw it out there. All the other languages are more, they're managed languages, right? Some of them don't even require a semicolon because I guess apparently that's too difficult to remember. All right, continuing on. All right, so yeah, this process repeats, creating a stack of function calls. Each call operates on a smaller version of the original problem. Once the base case is reached, the recursion unwinds. Okay, that's the LIFO part, guys. Last in, first out. It unwinds, so it's like you're going forwards and then now you're going backwards, sort of thing. We'll get into it. Totally makes sense. With each function, okay, but out of that. Once the base case is reached, the recursion unwinds with each function call returning its result to the previous call until the initial call returns the final solution. So I'm going to show you an example of that. Okay, but we're gonna do some simple ones for now. Okay, let's just work our way gradually with some basic, simple, easy ones. Okay, base case. It's a case where your recursion stops or ends after reaching that particular condition. Recursive case. It's a case where a function calls itself over again with decremented value until and unless it reaches its base case. Blah, 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 blah. Okay, I shouldn't have read that part because I think you already got the idea from what I read earlier. So last stream, hopefully you've been following the series, guys and gals. We're going step by step, gradually growing here in a linear fashion. If you didn't sleep in mathematics class, you'll know what a linear function is. Man, I love linear functions. They're so great. What a beautiful thing. Can I live 1,000 years, Lord? I just want to do math all the time. I'm not capping on that either. Factorial. We did a factorial, right? So now you have an understanding of what, how that works under the hood on your calculator. You actually seen the little mini program that does that. All right, we're gonna clean things up. Okay, there we go. Yes, I know. We're gonna build. We're gonna run. What the? Oh, ha! Because I didn't delete that. And let's go. I feel a sneeze coming on. Yikes. Yikesy doodles. Okay. Hold up, guys. This sneeze really is... It's right at the tip. Okay, maybe not. Maybe it's a... yeah. I think we're okay. Whew! Alright, we did a print. We could print numbers too. We could kind of do the same thing. The one that I just removed was a string, right? We're gonna do a void function. Okay, remember a void returns that has no return type, right? But you can spit out to the user, to the end user, some information. It doesn't matter if it's a string literal, which is a series of characters, or a numeric value, because you can. So we're just going to call it print nums, or print numbers foo, because I like saying that now. I don't know why. It seems fitting. We're going to input an integer value. We're going to take in. This is the parameter. It's going to accept a value from within the main. And then we're just going to do the same simple basic stuff. We're going to do an if statement, right? The condition has to be true or false, right? If you've been following the series, 1 is true, 0 is false. So if it's 1, it goes into the block of code, right? If it's 0, no entry. Okay, it basically just bypasses and would skip to an else statement if there was an else statement. You don't need an else. It's not mandatory to have an else with an if. But if you wanted an extra statement returned to the user, it could be anything that you dream of. You could say something like, I love marmalade, if that's how you spell marmalade. Marmalade. I can't even type, Batman. Marmalade. What's marmalade, boys and girls? What's marmalade? I don't know. What is marmalade? Just a random word that popped into my old brainium cranium? And there we go. It could be anything. I can't type worth a darn skis. You guys like marmalade? It's a fruit preservative. Marma. Lade. Look at me. I know how to spell. Good for me. Good for me. Making it fun over here, boys and girls. Having fun while we're learning. I do need to speed things up, though. So if n is greater than 0, ye must enter. And then we're going to do this. We're going to recursive. Just some notes for you guys and gals. Okay. And then we're going to actually just take that. I'm not done. I'm not finished doing my definition. We will do the declaration. Just got to remind myself to do that. Whoops. Let's go like this and like that. And there we go. It's calling itself now. It's officially calling itself Charlie. This function. Whoops. Its name is Charlie. I don't know why. It wanted to be called Charlie for some reason. Don't ask me, guys and gals. I have no idea. Okay, let's return n. because why not? And then we're gonna new line it, and boop, beep, boop, bop. And this is going to say, just gonna give you some extra notes. Processing. Notes for learning after recursive call. Okay, there we go. Okay, now I have to, it wants me to make it static. I'll guarantee it. Yes, it does. Okay, that's fine. That's fine, Bob. I'll make you static. Make you stationary. You want to be stationary? Okay, there you go. Now it's a happy function. There we go. Build, build, build. We're good. Okay. What? Where? Number 83. Okay. Errors are good. My typing's terrible, boys and girls. I could code. I could math. I could write grammatically correct sentences. I'm great at spelling. And I majored in mathematics. I love calculus. Yes, I've done calculus. Yeah. But I can't type. I just can't type. Don't cheat in typing class in high school. That's what I'm telling you. I recommend it. Okay. So it's saying I got a syntax. I'm probably missing maybe one of the operators. Okay. One of my overloaded operators. And it's right before the semicolon. Oh, look at that. Somewhere before the string, it's telling me which line. Okay, let's go to the line. Line 83. Oh, it's right here. Right there. Okay. Missing. I was missing 2, boys and girls. I was missing 2. Little things. Syntax and semantics. Okay. Don't be running around your room pretending that your hair's on fire, because it's not really that big of a deal, okay? Why so serious? Why do you have to make such a big deal out of it? It's just a little thing. Okay, let's finish up. All right, now we got to call our function. Okay, I could do the same thing. I could either hard code a value, or I could get a user to input a value. I'm just gonna do that. Okay, we'll do that. I'm just trying to maybe speed things up here because we got a lot to go through. And user, I should have maybe not deleted all that other stuff, but that's okay. User, please enter a non-negative, I'm gonna go like that anyways. Negative integer value. And if you weren't sleeping in mathematics class, you'll know what an integer is. And cn, and let's store that value. Yes. Okay. The key point, guys and gals, you just recalled, right? The compiler, when it runs in its recursive process, it reutilizes the last stored value, right? That's how it works, right? The value gets updated kind of on the fly while it's live, while it's running. It changes. It's constantly changing, right? Because of what? Wow, I almost had an infinite loop there, boys and girls. Pay attention, Bob. Pay attention. n-1, right? That's what makes it change. And if I didn't do that, and I'm glad I seen that, because you would have actually seen the infinite endless loop. I don't like doing that to my computer. I love my computer so much. I give it hugs every night. I'm just kidding. Okay? But I built it. I designed it with my own brain molecules. I went on the old local computer sales company in my area, went on their website, and slowly designed part by part my PC because, yeah, I have the, yeah. And I built it. So I want it to last. Okay, it's not a off the shelf potato PC calling itself a gaming system. Okay, it's a poser. Those are posers. Okay, all right. That's just PC real talk right there. All right, let's continue. Okay, and yeah, so there we go. I'm glad I went back. Right? I don't even know if this is gonna print, but you know, we'll see. We'll see what happens. Okay, let's call the function. Calling the function. Pass in the user entered value. And boom. Is that it? Is that it? I don't know. Let's find out. Run. Let's see what happens if I enter 0. I love marmalade. Let's go. Let's go. That easy, boys and girls. Okay, let's run another value. I love marmalade. Oh, it's still printed anyways. Interesting. So what it's done is, oh look. Why did it go 5, 1, 2, 3, 4? Kind of broke my brain a little bit. You would think it would go the other direction. 5 minus 1 is 4. What? First it's 5. Okay, print and first it's 5. Did you just like skip it or something? How are you doing that, Bob? That kind of breaks the brain a little bit. Guys, gals, okay? We could kind of try to have an understanding of what a computer does under the hood. We could rationalize it with our own theory and logic and all those sort of things. We could throw out these fancy coding words and all that sort of stuff. But really, bottom line, you almost kind of have to stop and just kind of deep think this one, right? You have to kind of like, what are you doing? What are you doing, right? So 5 is greater than 0, which is true. So this becomes true. It goes inside here, but this is the first call. So, but it immediately printed marmalade. Questions. I have many questions. And then it went n is 1. Okay, so it's almost like it went backwards. Wow. That's crazy. It actually deallocated. This is the deallocation step, I believe, boys and girls. The deallocation step. Wild sauce. So that is called head recursion. Okay? Head recursion. I'm going to put some notes here. Head recursion. Okay, that's an example. There's different types of recursion. Here's one example. Head recursion. The recursive call is made before any other operation in the function. Processing occurs after the recursive call returns. It is used for tree traversals and output generation. Okay, some fancy lingo and stuff. You kind of almost want to research that a little bit. I'll put the words in there for you guys and gals right now. It's not I know a lot of things, but I don't know everything. Okay, that's a new topic for me. Okay, and recursion, I'd kind of done this common stuff for recursion. I haven't actually needed it or required it in any of the programs I've been working on, but this is just one of those tools that is in your tool chest, your coding tool chest, and you can use it. You could decide to use it, or you could not decide to use it. It depends on what you're doing, right? What kind of end result you want with your program. Okay, so obviously there's different types of recursion. The factorial one we did yesterday, that's called tail recursion. Okay, I'll give you those little notes. Tail recursion. I'm just gonna go like this because copy and paste is much better than my typing skills. Man, whoever invented copy and paste, you're a genius. Okay, I'm not one of those copy and paste coders. Okay, I do use copy and paste a lot. I won't lie. But I'm the type of individual, if you knew me, I'm headstrong. And I like to figure things out first with my own brain molecules. I don't take the easy way out. I always do the hard way first. And if I can't come across a solution, I can give myself a pat on the back knowing that I at least tried first to figure it out. And then I'll resort to the internet or whatever and research. And then I'll decipher what's good information and what's bad information, right? That's how I do. Tail recursion, right? Factorial, right? Factorial. It's that, exclamation point that's on your, high school calculator. Okay, basic scientific. I got the engineering style calculator, so. But anyways, let's carry on. Tail recursion is a form of direct recursion. Okay, it's direct recursion. Factorial. There we go. Where the recursive call is the last operation in the function. So there we go, guys. That's why. Okay, head recursion. Wow, that's amazing, right? It's just the way you set it up in your code, in your if statement. That's wild sauce. Things that you didn't know that you could do, but now you know you can do, right? So, factorial, where the recursive call is the last operation in the function. It is used for solving accumulative Control C, Control V, there. For solving I brutalized that poor word. Accumulative. I got it, finally. Calculations and list processing problems. Apparently, cumulative is one of them words that I know about but do not use very often in my English speaking language. That's amazing. So now we have another one called linear. Okay, so linear recursion. Okay, I'm going to show you some cool examples. Okay, so there's head. All right. Okay, and head, here's the example for head, right? Whoops, where am I going, Bob? Tree traversals and output generation. Okay? You have options, boys and girls. You have options. All right, I'm going to get rid of this, but I'm going to keep that in case I need it. And we're going to start again. Control Shift B. Built. All right, linear. Okay, linear. Recursion. Each function call generates exactly one recursive call, forming a linear chain of calls. It is used for simple counting or summing. Okay, this seems like a common one, right? Pretty basic. Simple counting or summing, right? We could all do simple counting, right, guys and gals? Oh yeah, we can. We totally can. Okay, where am I going here? Right here. What? Okay, that's what it was. Control X. Control V. And there we go. Tail. Factorial. And there's one for indirect as well. But, okay. Let's do this one. This one's an int function this time. Okay, please take note. Linear recursion. Okay. Foo. All right. Inside is an if statement. And this time it's n is less than, my bad, or equal to 0. Not plus, equal to. Okay? Now, when we use less than and equal to, you got to realize that this is a test condition, right? So there's two options of it being true or false, right? It has to check both. It has to check, is n less than 0? And it also has to check, is n equal to 0? So there's two checks in there being done. Okay? Just as a heads up. And yes, we can return 0. All right. Okay, so return, right? Because it's an int. It's int function is a return type. We're going to return itself. Okay, n, don't forget the -1. Okay, that's critical. And then we're going to throw a +1 outside. Okay, this is outside of it. All right, and this is called call. Okay, it's still a call. We're still calling it, right? We're inside of a function. We're inside of itself, but it's still a call, right? Kind of like we're out here to make the magic happen under the hood and int main, we have to call it also, okay? All right, so, and we're gonna int n here, because the program's like, what is going on? I don't know what n is. Okay, I know it wants me to make it static. I'm just gonna go like this, like that, home, static, and done. There, okay, everything should be cleaned up here. We're good. Golden like Freddy. All right, quick build syntax again. Let's have a look. Oh, right here. Wow. Okay, my bad. All right, I forgot the semicolon. No, I am not a Python coder. I just oversighted it. Oversighted it. Okay, plus I was probably talking and thinking in 4D. Okay, carrying on. So now let's pass in that value. And what are we going to enter? I don't know. Linear, okay? Linear. Straight line. Okay, let's start off with 0. What does it do? Okay, it just breaks out of it. Okay? If it's less than or equal to 0, return, right? So if I put in a -1, it just returns. Okay, this is all normal. That's what a return 0 is, boys and girls. Let's enter a value of 5 and see what happens. Boom, it breaks out. Again, do I have, hold up. We're not really spitting out any information. That's the other thing, right? Return, oh, silly me. It's not a void, Johnny. It's not a void. Get with the program. Return result foo. Return the result, foo. Okay. More coffee. I don't know. It's not an excuse, I know. I gotta pay attention. What am I doing here? What am I doing? Trying to have fun and help you guys learn, okay? If you've been following the series, you'll know with a return type function, you have to create a new variable, which is gonna store the value that's on the right-hand side into the left-hand side, and then we have to that's the way this is how we have to pass it. Well, it's not really passing. This is how we input the information back to the user in the console in this particular situation. Okay, do I have an extra? I have a double enter right there. I don't really need another new line. Okay, I have this double enter here. Should be good enough. Okay, build. There we go. Now let's see the results of our hard work. Let's go 0 and see. There we go. It's returning 0. Beautiful. Okay. Let's pass in -1. 0 again. Interesting. Okay, and let's do it again. This time 5. Let's go. And it returns 5. Interesting. 5 minus 1 plus 1. It's used for simple counting or summing. Okay, so what we're doing here is essentially looking at it. It seems like we're not really moving forwards. You know what I mean? With the 0 we did, or the -1 we did, check it out. Okay, it brought it back up to 0 because it's going -1, -1. Wouldn't that be -2? Questions. +1, right? There's that +1 that's happening. Anyways, that's another tool in your toolbox, okay? A lot of different variations of recursion, guys and gals, and I'm just sharing with you the various types, okay? Yeah, recursion's one of those things. It's you learn about it, you know about it, you could use it in lieu of a for loop, if you will, right? I've done the most basic common recursion style. And I haven't really used these other styles. Again, there's more styles of recursion. So sharing this good information with you over the interwebs. And there's one called mutual recursion. Okay, which is kind of cool. It's a little bit longer. Let's see. Oh, okay. Oh, interesting. That's kind of cool. I like it. Well, I might actually do it. It's called mutual recursion. It's a form of indirect recursion. So this we've brought up these words, direct and indirect, and a lot of you are probably like, well, what does that mean, right? What does it mean? That's a good question. Directly or indirectly, right? For example, the ones that we just did were direct recursion, the tail recursion, the head recursion, the linear recursion. They are all forms of direct recursion. What is direct recursion? The function calls itself with a simpler or smaller instance of the problem. It is used for solving problems like factorial calculation, Fibonacci sequence, which I was thinking of showing you the Fibonacci sequence, but I wanted to kind of go over these little easy examples with you first. Okay? Fibonacci could be a little lengthy. All right, there we go. Okay, I'm going to try to spit this one out quickly. All right, we're going to create two functions. Okay, this is indirect recursion, and the type of indirect recursion, this one is called mutual. Okay, so indirect type, let's call it a type. Okay, it's called mutual. All right, it seems simple enough. Okay, again, it's this one's a void, so I got to remind myself this is a void. I don't need a return, and I don't need a variable. Okay, even foo, and it's gonna also take in int n, and go like this. And if, let's try to smash out this code quickly. If it's equal to 0. Why am I typing 0 all the time? I have no idea. Standard cout, even. And then, are we returning the value? I mean, I guess we could for testing. I don't know. Let's see. Right? In this situation, it's not really displaying n. But we'll display it just to see what it gives us. All right, and then this one has an else. And oh, wow, wow, this is cool. Check this out. So odd foo and n minus 1 mutual. It makes total sense. I like that. So what's happening here? I'm not done, guys and gals. Okay. Okay. I'm not done. Check this out. Two functions, okay? And they're basically the exact same thing, except one calls even and one calls odd. It's wild sauce. I like it. Okay? And even. I have not done this one before. This is cool. I like this one, actually. So here we go. Just want to double check that everything is correct. If n is equal to 0, standard cout even. I don't need all this extra, right? I could just spit out even, right? In a sense, I'm kind of just returning whatever the user enters. That's really all I'm doing. Okay? The even function is calling the odd function. Okay? And it's n minus 1. All right? Now, the odd function takes in the n, typical stuff. If n equal to 0, spit out odd. And we'll just see what odd is. And then even, n minus 1. Coolness. So now we have to create our static and go like that. And I'm going to go like that. And then we just have to do the one for odd. And I'm just going to go like that because they're basically the same thing. There we go. Okay, that should clean up everything down here. Now, what do we do inside here? Okay. We'll pass in some values and check it out. Oh, wow, this is cool. Okay, so in int main, we're going to call the even function. Oh, I'll just type it. Stop being lazy. Okay, let's call the even function. And we're going to pass in whatever n, right? Whatever I enter. And then odd, right? We're going to pass in let's see. They actually just hard coded. They put in some hard code values. I'm doing user entered values, so I'm kind of just winging it on the fly here. I'm gonna go +1 because really that's what it is. Oh, I have a question. That changes this. Is the value of n changing? I don't know. I'm not sure. I might end up hard coding it. We'll see what happens. Okay. And let's run it. Whoops. Where would I do now? 97. I'm bad at typing today, apparently. Today is bad typing day, guys. 84. Same thing, yeah. Why do I keep missing my beginning overloaded operators? I don't know. I have questions. Oh, I don't want to enter a value. Oh, yes, I do. Okay, 4. Even. It gave me 0 and 0. I was just curious what kind of value of n's. Well, I guess that makes sense. It's spitting out, just like I always say, guys and gals, it's going to return to the console the last known stored value of n, or your value, or your variable, right? So this is recursion, and how it ends is when it gets to 0, right? That's why it's spitting out 0. So now you know. That's part of the testing. We're always going to get 0. It doesn't matter what value. It doesn't matter what value we put in, because it's just going to print out the last stored value of n from in memory. Okay, right? The value keeps up changing and getting updated while it's running, right? It's recursion. Okay. Let's go 4 again. Okay, it gave me even. And which is true, is what I want. And that actually worked with me going n+1. But what I need here is actually a new line in front here. Okay, just so that we have it kind of returning to the console properly. I'm going to go 4 again. Even. Okay. In mutual recursion, 2 or more functions call each other in a recursive manner, forming a cyclic dependency. It is used for even and odd number classification and grammar parsing. Cool. Let me just, here we go. Okay. Boom. All right, I didn't say that part, so now you have an understanding. Okay, what's happening under the hood? Well, we're going to have to explain that a little bit, right? Even. Okay, I'm curious. So I'm going to hard code values. Instead of getting the user to enter values, I don't need this anymore. I'm just going to hard code it like they did. 4 and 5. This is what they had, okay? So I entered 4, so it should be 4 + 1, which is 5. That's why I went n value +1. And run. Same thing, even. And let's enter, I don't know, 3 and 4. See what it does. Whoops. Take note, we're calling this function and we're calling the other function, right? In the main. Odd. Ends up being the same, right? There must be... If it equals 0. Just trying to grasp it better under what's happening under the hood. It's kind of cool. Nested recursion. The nested recursion is a form of indirect recursion. This is going deeper into the recursion part than we really needed to, guys. Okay? But this, where I'm getting this information from, they probably got they got a pretty good site for various different examples. Really good site if you want to kind of go deeper into the understanding of recursion. I'm going to leave it at that, right? I don't want to be sitting here trying to figure out what's happening under the hood line by line. So, but we got to get to the point where we're talking about memory and that. I do have an example that I'm going to share with you. We are going to talk about that, but not from this code. We're going to talk about it from another set of code. Let's go here. Okay. Where am I here? So I've done this one. Remove that, and then we're going to do this one. Okay, recursion example. Which kind is this one? Let's see, summing. Oh, okay. All right. Here we go. I'll see. Oh yeah, this is cool. When the sum function is called, it adds parameter k to the sum of all the numbers. Okay, let me just type the code up here. Okay, another simple one here. Okay, so n value, I'm just going to make it equal to 10. For now, I'm hard coding literal constant, symbolic constant. Let's write, this is just a recursive example. I'm not sure if it's direct or indirect. Adding two numbers together is easy to do, but adding a range of numbers is more complicated. In the following example, recursion is used to add a range of numbers together by breaking it down into simple tasks of adding two numbers. Okay. Let's write it. Int. It's an int function. Sum foo. And this time we're just going to go int k. We're going to change the variable. It doesn't matter what you use. Same kind of stuff. Why do I do that? I don't know. Boom. If k is, it seems like it's direct, greater than 0. If k is greater than 0, do this. Return k plus the sum. This is where we're calling itself, right? We're taking the same value and then just adding it to itself again. Whoops. Okay. Oh, n minus 1. Don't forget that. This is the base case, right? And then else, really simple, to be honest. Else returns 0. Okay, we already know what a return 0 does, right? Just kind of exits. All right. Let's do the same stuff that we always do. And I'm going to make it static. Why not? Build it. Okay, everything's good. There's the function. Okay, it's going to go into either the if or the else. But the value k has to be greater than 0, not equal to, but greater than. If I pass in 0, it should end up just returning 0. So I'm going to go like this, and I'm going to first pass in 0, but I have to comment this one out. Okay, just so you can see. And oh yeah, I need an int return foo, whatever. Okay, return it foo. So return foo, because whoops, don't do that. That's why you can't use the word return, right? It's going to equal to some foo. We're going to call our function, and we're going to pass in n value. Okay, there we go. All right, I'm not even going to do user prompting just to save some time here. And then now we have to actually return that. Okay, results. Let's see what it does. And don't worry about the end line. Good enough. Okay, as a matter of fact, if I'm really worried about it, I could just go like this. I'm going to have a triple new line there. So there we go. Okay, good enough. All right, let's see what happens. It should just return, guys. Boom. Oh, do we have to? Oh. Okay, this looks like garbage. Now my brain's already thinking it's going, should we be referencing, dereferencing? What's up? 0. Oh. My bad, guys. I really am not thinking today. Return the value. I returned the function. That's why I gave back garbage. Okay. It's basically temporary lost in limbo memory. Okay, there we go. 0. Okay, get with the program. I need more coffee, apparently. Okay, 0. 0 is returned. Which is true because if I passed in 0, 0 is obviously less, right? So it's going to go to the else statement. It returns 0. That's the value it returned. Okay. Recall, guys. Okay. Sometimes you have to be a little more awake when coding to pay attention to what you're doing. But never return the function because obviously you get garbage back, right? If you get that in the console and you're wrapping your brain going, oh my God, what did I do? Right? Now you know. I like when these things kind of happen, maybe, anyways, it's good that they kind of happen. That way you can see what to do if you come across this sort of problem. Let's say this happens to you. Now you know how to solve it, right? It's a win for you. So let's enter another value. I don't know. 10. Right. We're going to do that now. So I'm going to get rid of this. First we did 0. Now let's do it with 10. Okay. Building. Passing in 10. We're passing in 10 now. Check it out. We get 55. Okay, so you're probably wondering, what does that mean? Okay, so here is what's happening. When the sum function is called, this one's cool. I like this one. This is a gooder. This one's a gooder. Note that we're going k plus whatever it returns here. This becomes a singular whole number too, right? Whatever happens here. 10 minus 1 becomes 9, right? 10 plus... Imagine it's 10 plus 9, right? And on and on and on, right? This is recursion. So what's happening is when the sum function is called, I could explain this one a little bit better. It adds parameter k to the sum of all numbers smaller than k and returns the result. So when k becomes 0, the function just returns 0. When running the program, follow these steps, okay? So here's what's happening. And this is a pretty good little breakdown of what's happening, okay? Under the hood, okay? Right? Just like I said, right? We pass in 10. 10 minus 1 is 9. That's where the 9 comes from. So then it becomes 10 plus 9, I imagine. And then it continues, right? This is kind of what's happening under the hood. Step by step. And it basically keeps going function-wise, right? Function-wise, that's what's happening. Okay, you can see the process. And it keeps going, right? This is just the shortened version. So here we go. Keeps going until we get to 0, basically. And then that's what you get. There's your answer, right? Whoops. That's what's happening under the hood. I'm not going to pull up my calculator and add up all that, but that's where the 55 should be coming from. Okay, 55. Always return your integer variable, guys and gals. Always return your integer variable, not your function. All right, let's go big yays. That's kind of cool, right? I'm showing you a bunch of different examples. Here's another one called countdown. Okay. All right, there you go. You guys can copy this code, test the code, do what you will. Okay. It's all open. Well, it's all open, right? Open source, essentially. You're just going to have to do all the typing. That's all. There we go. Okay. Build. Let's do another one. Okay. I am going, oh, it's a void. Okay. This time it's a void. So I'm not going to need that. But I'm going to be passing in the value 5 this time. All right. This one's called countdown. All right. It's a void. And we could just call it countdown foo. Same logic. We'll just use int k again. Why not? If k is greater than 0. Okay, that's our test condition. If this is true, it goes into this block of code. Standard cout. We're going to return n space. Okay, we're going to follow this syntax format. So what I've done here, guys and gals, okay, in this line of code or in this statement, I'm returning the value of n. I mean k actually, my bad. Okay. And then this creates a space. So it's going to actually spit out a series of integers, right? This here is basically putting a space in between each integer. That's what's happening. So now we need our base case, right? The base case is critical. This is the base case, right? It's our terminator. The terminator. And we're going to go k minus 1. All right, boom. That's it calling itself. And there is no else. I could have an else, but there is no else. Okay? Let's define it. And call it a static. And there we go. And boom. Done. Build. Hopefully I don't have any typos. We're going to pass in. I know I'm kind of going through this a little bit quicker, guys, but I'm trying to speed things up, okay? Lots of examples. And, you know, on the clock, countdown, tick tock tick. All right, let's pass in n value and run it. We're passing in 5. Okay, here we go. 5, 4, 3, 2, 1. Perfect. This is similar to doing like a for loop. You can still do this sort of thing with a for loop. Pretty cool. You can see the space in between, right? That's kind of key, right? Without the space, then it looks like it'll look like 54,321, and then your brain breaks going, what happened? What did I do? Right? Our mind looks at numbers or letters or characters and it actually interprets it, right? We get used to looking at things visually in a certain way, and we can only read it in a certain way, right? If I didn't have the space, then I'll just run it so you can see. It's going to look like a whole number. It's going to look like 54,321, right? You can see that. Let's drop the A's. That's it. Okay. Couple more examples of recursion. Whoops. I haven't really gone through the course outline much. And let's see, is there any more on this one? I was going to do this other one, yeah. Okay, we're kind of turning it up a notch here a little bit. This is the part where, to help you understand what's happening under the hood or on stack memory, okay? That one example, I wasn't really, what? Okay, go away. I didn't want to kind of explain what was happening in that one, right? Without kind of just wrecking it. But I have a better example here that I want to show you of what's happening on the stack when we actually pass in, like when we create variables, right? What's happening in stack memory, essentially. This is the under the hood part. Okay. I've already typed this code up, so I'm gonna just speed things up. I did this to save some time. And here we go. Sure. I just called it foo. Foo today, I called it foo. I'm gonna call it stack foo. Okay, we're gonna change it up. And I gotta make sure I update the information here. Okay, there we go. And here. And here. And then I'll let you look at it so you can see the code. Okay, everything's good there. All right, let's build it quickly. Everything's good. Okay. So, this example, this is kind of how recursion works. All right. How recursion works in regards to stack memory. All right, guys and gals, let's kind of go deeper into the thinking, not really the logic. I don't know, maybe a little bit the logic, but what is happening under the hood when you run a program, when you run a small little function, right? What's happening? What kind of magic is happening? So the first one is calling, let's see, what I'm going to do is I'm going to show you the simple one first, okay? To understand how recursion works internally, it's important to see how the call stack, right? When you hear the word stack memory or on the stack, it's also called the call stack, okay? Or call stack. Okay? To understand how recursion works internally, it's important to see how the call stack behaves during recursive calls. Okay? Right? Remember, we were kind of doing inline and all that sort of stuff. Again, take note, we're calling the same function over and over again. Right? We're not just calling it once. we're calling itself multiple times. So each time a function calls itself, the current state is saved on the stack. Okay, so like there's a current state, right? Whatever calculation happens, there's a state. It's saved on the stack. Okay, and then the new call begins, right? So the first call is saved, and then the new call is saved. Okay, once the base case is reached, right? The base case is what ends things. Believe in this case when it becomes 0, right? This example kind of shows what's happening on the stack, right? This is kind of really the only way to display it or show it so you can see it, right? Visually. Once the base case is reached, the function starts returning back one call at a time. Remember how I forget what I had said earlier, but it went backwards. Remember I said forwards and then backwards? That's kind of what happens. And that's the LIFO concept. Last in, first out, right? Again, the logic, again, I'll explain it. Imagine you have a stack of library books, okay? You're at the library or whatever, and you got a stack of books. Let's say you have 10 books stacked on top of each other on a desk or whatever. Pretend that's the stack, okay? Now, as the functions are being called, the first book gets put down, okay? And then when that function gets called again, another book gets put on top. That makes sense? And then you keep going and the pile grows. Okay, we're going from bottom up. Right? So book 1, book 2, book 3, book 4, and it keeps climbing. Okay, that makes sense? The last in, first out, when it goes backwards, it has to start from the top. So it takes the one off the top first, and then it starts deallocating that way. So it goes book 10 gets removed, book 9 gets removed, book 8 gets removed, book 7 gets removed, and so on, until this stack or all the memory is cleared up. That's the deallocation process. Okay? All right. The following example demonstrates both the descending phase, going deeper into recursion, and the ascending phase, returning back from recursion. Okay, I'm just going to go like this. Okay, so that you have that. Okay? How recursion works. Whoops. Oh, goodness gracious. Come on. There we go. I'm going to go like that. Yeah, and then I could go like this. There we go. A lot easier to read that way. Okay? And maybe I'll just go like that anyways. All right. And I'm just going to go like that because I kind of like things matching. Okay, there we go. All right, so here we go. We're going to return, this is the function name, right? And we're going to return whatever n is. And then we're going to say stack frame pushed. And then we're going to go into the if statement. N is greater than 1. Okay, as long as n is greater than 1, it's going to run the block of code in the if statement. Okay, I'm just going to show it with calling it once. Okay, calling itself once. Okay, and then we got this other statement outside our if statement, which says stack. This is the function name again. We're going to display the value at that current moment, right? And then we're going to say stack frame removed. It's kind of like the book concept, right? We're putting it on, we're taking it off. All right? So let's just do it for a low value for now. I'm going to create a new variable called, I don't know, stack value, or I don't know what to call it, to be honest. Maybe position. That makes sense. Maybe stack position. And we're going to just use the value 3 for now. Okay, good enough. All right, let's call the function. Pass in that argument. Boom. Okay, and this is all up here. And let's see what happens. Okay, again, I'm only going to call it once here, right? Just calling it once right now. Calling function. I know we're kind of going deeper into the recursion part of it, but that's what this video is about, guys. All right, recursion. And then we'll get into talking more about memory and all that. Okay, here we go. So this is the simple. Notice the value changes, right? Initially you put in 3, right? Stack frame pushed. And then it's subtracting here, right? Stack frame push, so it's going on. Book is on, right? This is going to be the first book on your desk. This is the second book on your desk, which is sitting on top of the first book. And this is going to be the third book, right? On your desk or on the pile, which is on the top now, right? So we have 3 books sitting on your desk at this point. And then it removes it off backwards. But essentially, it's the LIFO concept. It's got to take the first one, last in, first out. Last in, first out. Okay? This is the last in, right? Whatever the numeric value, don't worry about it. We could just pretend it's book 3, right? Book 3 is going to be the first one off. Okay? I guess I could have called this book 3 just to keep the logic in our brain. So we're going to first put book 3 on the desk. And then we're going to put book 2 on top of that. And then book 1 is on the very top of the stack. Okay? Now we're going to take book 1 off. And take the second book off. And the third book. You get the idea? Okay. So here's where it kind of gets wild. Okay, and it could kind of break the brain a little bit, but if you wanted to, you could write the code. By all means, you can write this code, copy the code. It's open source for you to learn. It's even on the old interwebs, somewhere in interwebs limbo, right? And you could sit there, at home and just kind of figure it out. And try to understand what's happening inside your RAM. Essentially, that's what's happening here, right? So I'm going to run this. There's a lot more going on, right? A lot more steps to kind of wrap your head around, okay? Now, I could give you, let's just do this, okay? I'm going to show you some visuals, okay? All right, one visual at a time here. Just to kind of help make things easier. Okay, here we go. All right, I'm not going to read all this, but it's there. Okay, there we go. Let's go to visual 2. There's 11 of them. Pretty good site. I just wanted to find more examples to share with you guys and gals. On the internet, right? Versus the one that I had in my course outline. The course outline goes into a little bit deeper. The program that I'm going to write from the course outline, I didn't want you guys to start running around in your room with your arms flailing in the air, right? That's that's why we went little bit, different concepts, baby steps here. Okay? That's the way to learn, at a gradual pace. Okay, here we go. This is what's happening, right? This is the logic, so that ourselves as individuals can kind of get a better grasp of what's happening when you run the program. Okay? Now, if you want to know where I got this information from, I mean, you could comment in chat or post a comment if you want. I have no problems letting you know where the source is from. Maybe I'll even try to put it, in my description or in the comments or something as well. Okay? And again, this is just to help give you a little bit better of understanding logically in the mind of what's happening. Okay? And to save you the pain of me reading it, right? You could kind of just play the video, pause the video, read the portion, take notes, do whatever you have to do. And now you're going to have a little bit of a better understanding of what's happening under the hood. Okay? You'll hear that under the hood a lot. It's thrown around a lot. I imagine it's thrown around a lot more with C++ than it is with any other language. Right? All the other languages are managed languages. What does that mean, boys and girls? What does that mean? Well, we're going to get into that. Stay tuned. Hopefully I haven't missed any. Okay, you can screenshot, snipping tool this, save this for your own self. If you're on PC or whatever, or a laptop, I'm sure, snipping tools is a Windows thing. So, I'm on a dual monitor system in case you guys are like confused. Yeah, because I can. I have the know-hows. All right, we're almost done. Almost done. I'll read a little bit more information, and then we're going to talk about Fibonacci. Fibonacci! It almost makes me want to have lasagna. I made lasagna once. It turned out pretty good. Shocker. That's right. I could be a maninist. I don't need no woman. It's actually true. My mom raised me to know how to cook, do dishes, all those sort of things. Clean house, clean up after myself, and I still have my manliness. I'm a maninist. I don't need a woman. Just kidding. I love women. Okay? If any girls want me, I don't chase, so done with chasing. Okay, there. Okay, so it's a lot going on to kind of try to wrap your brain around, right? We don't want to scare you off. All the different recursion things that I've shared, it's kind of like, here are the tools. I just showed you all the different tools. Each tool is basically called recursion, but they have a different purpose in a nutshell. Okay? Memory management and recursion, like other functions, the data of a recursive function is stored in stack memory as a stack frame. Okay? Just more wordage, verbiage, guys and gals. Just think on the stack memory. It's just a position in your memory, stack frame, whatever you could call it. It's just more wordage, more verbiage. This stack frame is removed once the function returns a value. In recursion, the function call occurs before returning a value, so the stack frames for each recursive call are placed on top of the existing stack frames in memory. Right? The library book concept. Once the topmost function returns a value, its stack frame is removed, right? So you could think of this, you could think of the stack frame as the actual book, right? If that's the logic to help you remember or understand all this, makes sense, right? It's a good little visual in your mind. And control is passed back to the function just before it, right? It passes the control back to the function before it, right? That's what's happening. Resuming execution after the point where the recursive call was made. The compiler uses an instruction pointer to keep track of the location to return to after the function execution is complete. So inside the compiler creates kind of this, think of it like it creates its own Excel spreadsheet or whatever. Just as an example, it keeps track of that data, right, in the order of operations and execution, right? Because then it knows itself what it needs to do, right? There is more to it than that, but that's really the most simplistic, easiest way to explain the analogy of what the compiler is doing when all this magic is happening, right? It creates its own little Excel file. It's not actually creating an Excel file, okay, guys? It's a hypothetical. Unlike iteration, recursion relies on the call stack, making memory management a key differentiator between the two. Okay? Okay? Keep that in your mind. Recursion relies on the call stack. All right? There's a concept called stack overflow. Okay, this is all in regards to memory, right? This is bad. Stack overflow, these kind of things, yeah, no bueno. Stack overflow is one of the most common errors associated with the recursion, which occurs when a function calls itself too many times. Okay? It creates, it's a lot of chaos going on, right? You got to be careful when using these things. As we know that each recursive call requires a separate space in the limited stack memory. When there is a large number of recursive calls or recursion goes on infinite times, the stack memory may get exhausted and may not be able to store more data, leading to program's termination. Okay, think about it, guys, right? Think of the stack as a library, okay? And the library has so many cubicles, if you could, book shelves, book cubicles. Let's say they have hypothetically 100 of them. Okay, once you fill up all those stack shelves, there's no more room, right? It's full. Okay, but the program, things are still running, things are still happening. Once you fill that library, that's it. Things are breaking at that point. Okay, that's why memory management is key. Okay, you got to keep your RAM, free of space so that things can happen. Your programs can do things, okay? Anyways, there you go. That's it in a nutshell. I hope you love that. We are kind of getting up there in time. Again, we've covered a lot, I think. Stayed on topic as well. If you need to pause, play, all those sort of things, by all means, guys, gals, it's great to have you here learning. I hope I'm helping. I haven't myself per se gone too deep into recursion stuff. It's one of those things, you know, you learn the first recursion process. It's just another tool I could have used. But for the most part, I've just been working using for loops or iterators, you know. Recursion is just another tool in your line coding tool chest, okay? That's what it is. All right, I want to finish this up. We're going to get into Fibonacci. I do have one little program to write up. I got to speed this up. What is Fibonacci? Okay, what is it? All right. I'm going to share this with you. Let's see. I'm just going to do this. Okay. It'll be easier. Okay. Okay, here we go. Simpler. Okay. How Fibonacci works. The Fibonacci sequence works by having each subsequent number be the sum of the two preceding numbers, right? I want you guys and gals to understand like how the Fibonacci works in your mind, right? I could write code and stuff and spit out a bunch of information, but I mean, then you're going to be just running around tripping over your shoelaces even though you're not wearing any shoes, right? I don't want that. Okay, so by having each subsequent number be the sum of the two preceding numbers, starting with 0. So 0 plus 1 gives you 1, right? 0 plus 1 gives you 1. 1 plus 1 gives you 2. 1 plus 2 gives you 3. 2 plus 3 gives you 5. That's how it's working, right? And so on. 5 plus 8 is 13. Or 3 plus 5 is 8. 8 plus 3, you know, you're getting the idea, right? This mathematical pattern appears naturally in many forms, such as the arrangement of leaves on a stem, the spirals of a pineapple, or the branching of trees. That's probably that logic that I was talking about earlier when I used that word trees. There you go. Fibonacci is an example of it, right? I don't know. It's a mathematical understanding of nature, I guess. Sure, let's roll with it. Start with two base numbers. The sequence typically begins with 0 and 1. And the last two numbers, to find the next number of the sequence, you add the last two numbers together, right? You get the idea. Okay? Pretty straightforward, right? Okay, let's write up some code. And then we're going to get in. Next stream is going to be getting into how functions work, a peek under the hood. And then we're going to get into talking about memory more, right? Let's get out of this recursion part, okay? This is it for the recursion, okay, guys and gals? I think that's enough torture and pain, right? I must agree. Okay, let's see. Here we go. I'm just going to go like this. There we go. And let's type up. It's an int function, boys and girls. And then we're going to call it Fibonacci. Food makes me want to. I love lasagna. Just think the Italians, man, they know their pasta. They know their pasta. Love pasta. I'm going to use, I don't know, let's use F for Fibonacci. Actually, you know what? To be honest, I forgot something else. Was it here? I want to see if I can find it. Yeah. Okay, who is Fibonacci, right? Here we go. Okay, I wanted to share this as well, right? It's one thing to talk about the Fibonacci sequence, but who was he? Who was he? The Fibonacci sequence, commonly attributed to the medieval Italian mathematician Leonardo Fibonacci. Let's go! Man, that's a long time ago, huh, boys and girls? Yes, it was. Has a rich history spanning multiple civilizations and millennia. Fibonacci, also known as Leonardo of Pisa, formally introduced the sequence of Western mathematics. God bless mathematicians back in the day. Oh, I love those guys. Just think about it. They didn't have internet and all that stuff. Bored syndrome. What else do you have to do other than just grind and learn, right? Spoiled nowadays. I love learning. I don't know. Learning. Yeah, don't be that guy, okay? Okay, there you go. Okay, there's a formula too. Pretty awesome. Okay, continuing, we shall. I'm just gonna go like this. We'll just we'll put the definition now. I think it could be static. And I'm gonna actually, okay. What? Oh, that's what it is. There we go. Silly me. I'm gonna call it LF. Leonardo Fibonacci. Okay? Alright. We'll do a standard cout. Let's type some code and finish up here. Processing. Processing, meaning we're processing the function. Okay? And then I'm just going to call it FibFoo. Good enough for short. Alright, guys and gals? And that's that for that. And then let's go like this. And then we're going to return LF. And then we're going to also close it in brackets. That's what I'm doing here. Just the way the syntax is written, guys and gals. That's all it is. Okay, it's a string literal between a value and a string literal again on the left and right. That's all it is. You got to follow the syntax. All right, so if LF is less than 3, standard cout, return one not. We'll see what it says. It's going to return 1. Okay. All right, and yes, you can do that. Okay, else. Brackets are kind of like an operations thing. Okay. Obviously, right? It organizes your code. It's not like I really need it there, but in regards to passing by pointer and such and dereferencing, you kind of need it. All right, so I just want to make sure I don't mess this code up. We're passing in LF. We're printing the value initially. If LS is less than 0, return 1 not. Return the value 1. Else, standard cout. We're calling FibFoo. Means we're calling our function. And it's going to be here. I'm going to go LF minus 2, right? The way this is set up, it's not real. It's not like you'll see, right? It actually returns a different value than you expect, which is kind of neat. All right, it's kind of like this function. The way it's being created is to actually return us a value or a position, in a sense. You'll see. I just want to make sure I have things typed up properly here. And whoops. And fib foo. LF minus 1. Okay, I could put those in brackets too if I wanted to, right? Maybe create some organization with the code so it makes sense. And then we're going to return not a space, but closing brackets, a decimal, and a backslash n. It's a period at the end of our statement. And then we're going to here, because it's an int, we have to return still. We could actually return information, but it has to be before the return, okay? So here's where it gets wild. I've made the name a little bit long, but whoops. Okay, and then we're going to first pass in n minus 2 plus n minus 1. Okay, and this is our base case, right? Okay, now I just got to make sure I've typed it all properly here and I don't have things messed up. Okay, n minus 2, LF minus 2. Oops, I do have things messed up. I got n in my brain. Let's use the proper variable. LF minus 2, and yeah, the space is right here. No enter, so this is going to be inline when it's returned to the console. And baba. So what we're doing here is just returning whatever is here and returning whatever is here. That's what we're doing, guys and gals. That's what this is doing. I could put it in a variable, but it's best to do it this way. Remember, if you create a new variable, it's just another place on stack memory, right? Taking up space. The less is more, okay? Less is more. So we're returning. Do I have all my brackets right? Yes, I do. Okay, make sure you have matching brackets. This is the brother. This is the sister. This is the brother. This is the sister. This is the brother. And this is the sister. Okay? All right. I think we're good. Okay. So in the main, because remember, if you're using a return type, you need, let's see, what are we doing first? What? We're getting a user to enter a value. So we're going to go end value again. User entered. These are local variables, right? And then I need 1, 2 for the answer, right? Answer foo. Okay. It's just random names, guys and gals. Okay. And it's going to be 0 as well. Because, well, all we're doing right here is declaring them. Okay, that's declaration. And then, so now we're going to get user, enter a number to find. Okay, and then I don't know, I'm just gonna put something like, just for, respect purposes, because we don't want to forget his name, right? Define. Okay, we're looking for him. Okay. I'm gonna go right there. Okay, instead. I wish I could kind of explain what's happening with that better, but we'll just run it so you can see it. It's better just to see than to talk about it, to try to explain it. Okay, there we go. All right. And I could actually have a couple of enters here if I wanted to. If I needed them, I can. We'll just put a double enter, double quotes. Okay, and then return. Now we have to call the function, right? It's got to equal our function name. This is the calling the function part, right? All right, and we're passing in end value, right? That's our end value is our argument. Okay. And then let's return that information, right? From our function. So the answer, okay, is this is to help you understand what this function is doing. Okay, it's a bit of a breakdown. And standard cout again. There's no enter after here, so again, this standard cout is going to be printed inline in the console. So remember how earlier I was, just to be clear here, I have to finish up with the code. Just to be clear, okay, so the function that I'm typing here isn't doing this. It's not doing the adding part. Okay, I just want to be clear on this. We could do it. We could do this, right? We could. But what we're going to do is we're going to actually bring up the value, whatever position 8 is, for example. It's going to return the position, okay, based on all the calculations, okay? That's kind of the best way I can explain it, but that's what's happening. All right, just so you understand. Where am I here? It's a position, okay? And /n and finish. And then return 0. I think that's it, okay? That's it. Okay, here's our function. Again, we do have to have that base case, right? I believe this is the base case up here, to be honest. I don't want to confuse you guys, right? If it's, yeah, this will bring us out here, right here, right? This is the base case. I do apologize. I don't want to say the wrong thing here. This is the actual recursion. My apologies. Okay. Base case. And here's the recursion. recursion process. Okay. Of course, I didn't type that right. There. Okay. Just to be clear. And then we've declared a couple of local variables. One of them has to accept our answer. The return value from our return type function gets passed into answer foo. And then here we're just displaying answer foo. And it's going to tell us is the blank, whatever position, this end value is changing under the hood. Okay. I know you're all excited to see, so let's do this. All right, running. Boom. User enter a Leonardo Fibonacci number to find. Okay, we're gonna enter 6. Okay. Lots going on, but you can see all the steps, all the recursion. This is kind of the LIFO stuff that's happening. Okay, this is all part of the LIFO. So you kind of have to work backwards in your mind what's happening here. 6 is 5, 5 is 4, and so on. 3, 4, 2. You can kind of see the pattern a little bit, right? And 8 is the 6th Fibonacci number, right? So with that said, let's bring this up here and see if we could actually see it. Remember, it started with 0 and 1, right? So the 8. 8 is the 6th Fibonacci number. Aha, yeah. So yeah, that's what it is. It's going forward. 1, 2, 3, 4, 5, 6. I wonder if it counts to 0. I'm not sure how that works. But just to kind of, whoops. That wasn't what I wanted. Settings. Yeah, no. Okay. Oh, here's 8 right here, right? 6, does it count to 0? You'd think the 0 would be counted. 1, 2, 3, 4, 5, 6, 7, right? Position 7. Anyways, that's the gist of it, right? 8 is the 6th Fibonacci number. And we're still, the way we've written the code, we're still doing recursion, guys. It's just done in a different way, and the outcome is different. That's all, right? We're not counting forward. We're actually figuring out a position. Let's run that again. So I'll put 6. And then it kind of here, this is all the under the hood stuff, right? This would be the deallocating part, right? Deallocating. That's kind of what we wanted to express. I want to actually enter. We need an enter like rates. Like right here, maybe. Just put a new line here. Control X. Right there. And then I'll run it again. Okay. Okay, position. It's a position. I'm going to leave it at that. That is it, guys and gals. We are done with recursion. I know it was a lot. There's obviously a lot of different things that we could do with functions. And this is adding to your C++ coding toolbox. Turn it up. Let's go! Whoops. That's not what I wanted. Okay, I'm going to leave it at that. Hopefully you didn't get scared off. Okay. Okay? As you guys, gals, as you advance with your skill set and your line coding skills and your syntax and I mean, this is all knowledge you have to kind of learn, right? You can keep you can keep moving forward in your learning coding journey. Remember, stay positive, right? I want you guys to stay positive. Don't get frustrated, please. Okay? There are going to be days that might be challenging, and that's okay. If you need, just take a day or two break from it, have a rest, have a little bit of fun, ease your mind, and then get back to it, right? A lot of times when you kind of just step back from something, you could approach it again, and then you'll be like, whoa, wow, was that ever? Oh, now I get it. You know what I mean? So we've done a lot of things in regards to recursion, right? We've learned a lot of different things, a lot of different ways we could do recursion, right? A lot of different types and methods, if you will. You could use that in the future as you advance your coding skill sets, right? It gets easier. Trust me, guys. It gets easier as it goes along, right? Sometimes, code like this, you kind of just step away, you come back to it, and just spend a little bit of time just kind of analyzing it and breaking it down in your mind step by step. It's a lot easier to do it that way, taking the time, give yourself a few hours or whatever it takes to kind of just break it down and analyze it. I wish you all the best. Johnny with Whiskey Tango Sharp Coding. I appreciate you all, every single one of you that have been watching. If you're listening to me right now, you are a legend. You are a legend. You truly are. You beautiful, intelligent, 120 IQ and higher individual that you are. It's great to have you. I'm going to leave it at that. I got to go. I'll see you in the next live stream. Whoever you are, wherever you are, take care. Have an awesome rest of your day, evening, night. And that is it. Johnny with Whiskey Tango Sharp Coding saying peace out, guys. Talk to you soon. Take care. Peace.
Baby, I don't understand this. You're changing.